So I have started recording the session. As I can see, there are 52 students. So let us proceed with the today's class. Now today's class is more of, the task oriented, meaning we have already discussed the programming aspects of singly linked lists, and in first half of the class I'll just tell you what are the things that you are supposed to complete by the end of probably this week, or by the end of the second week mid. Okay, so those students who are having laptops or who are having the computers, okay, let us take up one by one. Can somebody acknowledge, am I audible?
Yes, sir.
Okay, fine. So first point is about the lab. Okay, so let me open the, give me 1 minute. I'll open the list of programs which I have already communicated at the starting of the semester, which I have asked you to start executing on timely basis by the time when you are coming to the labs. Okay, so let me open the list of lab programs. So if anybody has the access, you can view, or else I'll again share that. Okay, so I'm talking about lab micro course plan. So let me share this also, and then further instructions we will move on. Okay. So before that, I need a confirmation from some of the students whether have you started executing the programs with the hardware, or with the platforms which are available with you. Have you started executing linked list programs? Have you started executing? Can somebody acknowledge? Can somebody acknowledge?
Yes.
Okay, fine. Okay, so if I am correct, then in the lab, can somebody tell what was the last program which I have asked you to execute? I think it is somewhere around operator overloading 32.
32.
Okay, so 32 programs I have asked you to execute. Now 33 is based on files, so you leave 33. Okay, so is the PDF document what I am sharing is visible?
Yes, sir.
Okay, fine. And this 34 is public inheritance, which will demonstrate the static polymorphism. I think this also we have started when we are in the campus. Okay, so 34 you have to complete. 34 is dynamic polymorphism, which is nothing but runtime object binding, or as well as the concept of virtual functions, pure virtual functions, and the definition of abstract base class with a zero initializer. So this was our first topic of interest that we have started our online sessions. So 35 has to be completed. Okay. Next 36 is the order of constructors and destructors calling. So you start including the simple inheritance. Then when you are when you are writing the when you are implementing the programs, take the same classes as we have discussed in theory, like ABCD, and then understand how many times the constructors and destructors are getting called, and explicitly for this fellow, which is hybrid inheritance, make sure that you will get a error. Okay, now for all the programs that I am discussing now, you have to start executing the programs for those students who have computers, or for those students who have laptops, and even for those students who have mobile phones. Okay, so as I can see, there are three categories of students here. Can somebody respond? Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so there are three categories of there are three variants of students here. One is students are there which are having internet connected to your desktop or a laptop, I think you can straight away use a installed C++ compiler and then start executing. Okay, so these are first category students where you have both the smartphone as well as laptop or computer. Now there are set of students who may be having computer but who don't have internet. So okay, so for those students, I recommend you download a C++ compiler on mobile, and then you copy that into your pen drive, or you take a cable and then from the cable you copy from the phone into your system and then start installing a offline compiler. So once you install a offline compiler, then you can start experimenting, because programming on a computer is always advised than the mobile phone. Okay, so am I clear? Please be interactive. Am I clear?
Yes, sir.
Yes, sir.
Okay, so next is there are third category of students who don't have neither the laptop nor the the computer, and who have only the smartphones, who have only the phones. Okay, so for these students, what you have to do is please start collaborating with the entire class. Okay, so sooner this document is available, this PDF document is available to the entire class. Okay, so there is no harm in communicating the source code of all these programs onto the Google groups, so that that rigorous typing in the mobile can be saved. Okay, so instead the students can copy the source code and then start executing, but only after executing the programs, make ensure that everybody are writing in the records. So writing record activity also has to be started. So don't hang on, because we were told to instruct the students even to complete the lab records on time and on par with covering. I think somebody's microphone.
Sir, there is
My
no
voice is
record
getting echo.
papers means. Sir, there is no record papers means.
Yeah, I'll get back to that. Coming to the record papers, what I'm asking you to do is there is no need of record papers which are printed with Vasavi logo and so on. So probably you can go to a book stationery shop and then take a bundle, okay, A4 size papers, and then directly start writing the programs with the pen on one side, on single side. Am I clear? Am I clear?
Yes, sir.
Okay,
Yes,
so
sir.
I think
Yes, sir.
yeah, I think government has given the permission to open the books, so bookstall. So, sir, how to do 37 program? 37 program we have discussed, right? Let us go one by one. Okay. So, am I clear in terms of writing the record? So, also,
Yes, sir. Yes, sir.
yeah,
Yes,
also
sir.
make ensure that I think some is still on, maybe 125. Anusha, can you? Yeah, now it is fine. Yeah, now it is 5. Now it is fine. I think, yeah, 125, fine. Okay, so as we have been practicing in the earlier, physical classes, what you do is make ensure that you are understanding the concept first. Okay, so if at all there is a need of clarity, please go through the online interaction that we had for the last 10 days or so. And I have also shared the prescribed textbook, which is a recent edition, which is a 10th edition. Did I think I have shared, right? Can somebody respond?
Yes, sir.
Yeah.
Yes, sir.
So first, make ensure that every student is understanding the concept. Then second is make ensure that whatever programs that we have executed online, you are also in a position to compile and technically understand what is happening in the program. Okay, so then third is you take this PDF and then start understanding the problem requirement. Okay, and then you start coding by your own, right? So in that process, you can also interact with your other friends and then exchange the code. And this exchange will be really helpful for those students who are not having the laptops or desktops. Okay, so for those students who are having only mobile phones, you can use an online compiler like the one what I have been using, a GDB or Dev C++ or any other online publicly available compilers. Okay, so but you copy the code what has been written by your friends or by me or by somebody, but make ensure that you are understanding. Then only you compile. Okay, so don't bluff to yourself. Once you are done with that, immediately take a A4 size white paper, A4 sheets you take, and then you start writing the record with the pen. And there is no need to polish. Okay, so just start writing the record, whatever programs which are being given as the list of programs in this PDF. Am I clear? Am I clear? Can
Yes, sir. Yes,
Okay.
sir.
Yes, sir.
Now I am asking you to compile and execute all the programs that I am telling the list now. So till 36 except that the files program. Okay. Next is 37. 37 also we have discussed. Did we discuss? Yes or no? Let me go through the problem requirement once. So 37 is demonstrate the concept of explicit parameterized base class constructor calling in the derived class parameterized constructor initializer with a suitable example. I think we have done this. I have taken some small 5 minutes or 6 minutes in sometime in the last. Did I? We have discussed this. Yes or no?
Yeah.
Yes or no? With a single colon, I have discussed how to invoke. I'm sorry. How to invoke the base class constructor when you are creating a derived class object by explicit parameterized constructor. I have, I think I have discussed this. Yes or no? Can somebody acknowledge? Yes or no?
Sir. Yes, sir.
Explain one
Yeah,
function, sir.
we have
We have to.
discussed. That sample example itself is enough. You must be in a position to demonstrate that the base class constructor also can be called by using a derived class constructor when you are trying to invoke a derived class object. We have discussed it. Okay, so I remember very well because this was the topic I have initially discussed to section C and then to section A. Any doubts? Can somebody come in? Did we discuss yes or no? Other than probably Pradyumna has told me just now. Other than Pradyumna, anybody else please acknowledge? We have discussed this.
Yes, sir. Discussed.
Yeah, okay. Next, 38 is VBC, that assignments, quizzes, virtual base class, and then diamond problem.
Sir.
Okay, so that is 38. Then 39 is implement a template function for finding the biggest of given three entities. Attaching a C++ template function. Writing a C++ template function for finding the biggest of integers, real numbers, characters. We have done this. Yes or no? Yes or no?
Yes, sir.
Okay, next is class template. In class template, again, we have also looked in how to combine a generic array and then apply linear search and find biggest and smallest entities and demonstrate this with integer and for names. That means name is nothing but your string. Okay, so 40 is also completed. 41 is again you implement class template and apply the concept of selection sort and also binary search. Maybe I think if I remember well, we have done selection sort and linear search. So once what you do is you do the selection sort and then you apply the concept of binary search, finding the mid and then traversing based on the key. Okay, and demonstrate for integer and for names. That is 41. Clear? 41 is also completed. Yes or no? Yes or no?
Yes, sir.
Okay, next 42. Implementation of a singly linked list without a class. No, sorry, with a class, with a class. C++ class to maintain the head node with the basic functions. Creating a head node, adding a node at the end, adding a new head node, and then inserting a node after k nodes. But for every program, you need to keep display function. Okay, so here what I do, what I advise is you write the linked list program entire class in only one, starting of 42. Okay, so you write all the functions that are being asked in 42, 43, then 40, only 42, 43. Yeah, these two programs. Okay, so there is no need to repeat the entire code what you are doing in 42 in 43 because creating the head node is same, adding a node is same, okay, adding the node at the new head is also same. Whatever extra functions which are asked for you to implement, you start writing the functions, but you implement that as member functions. Now notice that in the class we have discussed as a C++ general functions, and in the lab, in the online compiler also I have executed with the member functions. So this is where we are in. That means up to 42 and 43 is also completed. Yes or no? Up to 43. Creating, adding, then adding a node, adding a new head, deleting the node after k nodes, deleting a node. We'll see some of the logics today. Okay. I'm sorry. Then inserting a node after the last occurrence of x or before x. Some of these logics we have seen, and we will see some of the other logics like sorting and searching or deletion in today's class. Okay, so up to 43 list of programs you are expected to complete when you are coming to the next class. Next week. Probably you can put it in next week. Am I clear?
Yes, sir.
Yes, sir.
Yes, sir.
And all of you please make ensure that you are using the online resources effectively and participate in terms of collaborative learning. Meaning some students might be having computers and they are all enjoying the benefits of internet and having are being located at city. Okay, there are some of your friends who are located at remote places for whom the connectivity is a problem, laptop is a problem, hardware the computer itself is not there. Okay, so I recommend all these programs, if possible, 1 to 43. All the programs you put it in group by keeping program number. Let us say P1.cpp, P2.cpp, and so on up to P43.cpp. Okay, so group is for our benefit. So you can make use of this group for effective collaborative learning so that other students need not have to type. Am I clear?
Yes, sir.
Sir.
Okay. Okay, so let us let us see some other details. Before I proceed, is there any problem in terms of executing the programs and writing the same programs in regard? If anybody has any problems, if anybody needs to address any of your issues, you are welcome to raise now. Please use your mic. Who is this 151? Who is this 151? Ask roll number 151 to call me. I think he's making some nonsense text here. Spellings, whose spellings he is talking about? 151, are you there, Rishi? 151. Is he there? Yes or no? You use your mic, Rishi. What is this? I didn't understand. Rahul A spellings. I'm not discussing anything which is related to English, I suppose. I also don't consider myself as a poet, so I know my English is also little, by mistake. No, 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 no. It is implied that students are using private chat. Please make ensure, please listen and please understand what are we doing. Okay, so this is a platform where a faculty is interacting with 60 students. For any other things which are of your personal interest, there are other platforms which are free of cost like Facebook and other things. Please do engage yourself into that platform. Don't bring your private chats here. For your information, everything is getting recorded. Okay, so we also have the Cisco collaboration with Vasavi. So whatever we are hosting on WebEx, which is a product of Cisco, is getting recorded. Okay, so there are some very bad cases which are coming in from your other classmates. So I also advise, or rather insist, not to involve, or if anybody is interrupting you with any of the private chats, just to take a snapshot and then keep that snapshot or send that snapshot to your class coordinator. Don't again throw message privately, then you will be in trouble. I hope you are all listening. Are you listening? Are you listening? Are you there?
Yes, sir.
Yes, sir.
Please don't use private chats. This is not the platform. Okay. Yeah, I think there are some other comments. What are that? What is it? Sir, how to do 37 program? 37, I think I have discussed. Anything else? Explain once again. Which one to explain once again? 146.
37, sir.
That is 7. Probably you go through the video which I have already shared at the time of presentation, because otherwise we'll be lacking in the syllabus. Okay. So once if you require the repetition needs to be done, I'll do that certainly. Okay.
Yes.
Okay.
Yes.
Okay. Fine. Fair enough. Any other doubts? So shall we proceed? Shall we proceed?
Yes, sir.
Okay.
Yes,
So
sir.
in today's class, what we will do is we will. Did we implemented C++ classes with a single linked list in the last class?
Sir, at ending, you shown all the slides, sir. Not implemented and
No, no, no. I'm
not
talking about
implemented.
implementation. I'm talking about implementation. Did I at least have implemented a C++ class with a single linked list? Did I combine?
Yes, sir, but
Yes,
not
sir.
with all the member functions, sir.
Okay, not with
Yes,
all
sir.
the member functions. So what I'll do is, just correct me if I'm wrong. What I'm making a statement here is, I have as of now implemented a C++ ADT class with a single linked list construction, probably a single linked list which is maintaining an integer, such that we are throwing the options to the user. One is to create a head node, and second is to add a node at the end, and then third is probably display, and fourth is exit. So this is what we have done, if I'm correct.
Yes, sir.
We have done this, right?
Yes, sir.
Okay, so on top of this, additional functions, I think I might have rushed through in the last class. Now let us look into some of the aspects in today's class. Okay, like that also includes the sorting, searching, insertion, deletion, and here you will appreciate the importance of C++ single linked list. Okay, so let us proceed. So add a new node just before the tail node. What I'll do is, as I have already explained in the slide, I have written a function which is normally asked for 2 marks. For example, the question goes like this. Implement a C++ function that has to accept the root node of the single linked list and the value k that needs to be inserted just before the tail. Okay, so that means there is no need to write the entire linked list program. You have to write whatever is visible on the screen. So, are you following? So this is a logic in order to add just before the tail. So let us assume that you are asked to add the value which is equal to 47. Can somebody acknowledge?
Yes,
Yes,
sir.
sir.
Okay. So now what I'll do is I'll go to the code. Where is that compiler? Okay, and I'm going to open the same program which I have saved for during your last class, which is class number 8. Just opening it. Just give me 2 minutes. I'll open and then I'll put in the IDE because otherwise it will take the entire 1 hour. Okay, so lecture 8, singly linked list. But in this, I think I have also implemented the other member functions. Wherever the other member functions were not explained, in today's class, I'll explain all those member functions. Can somebody respond? This was the, is this is visible? Is
Yes, sir.
visible?
Yes, sir.
Okay. Okay. So let me run through the program once. Structure, class, node star head. Okay. Creating the node and add X from the head. Add at X from head. Do bubble sort, do selection sort. This I have added and I think I have communicated. So in today's class, I'll explain how the sorting and searching is done. Okay. Now this is add at the end. This logic is clear, right? Next, creating a head. Then this is the display logic. I think we have also discussed the display logic with recursion. And then display at X from head. Display at X from head. Here X is nothing but K. So you have to traverse the node till K times. You have to traverse P, which is line number 77. And then you have to create a new node temp. Okay. And you have to attach it. Finally, this is the destructor. I think I have not done the, though I have written the member functions of selection sort and bubble sort, we have not done that. Now here, what is R1? R1 is an object of list class. 1, 2, 3, 4. 4 is add a node at the X from head. Let me check whether that has been implemented. Yeah, that has been implemented. So I'll continue doing the other cases. Now case 5, what I'll do is a node at the tail. Okay. So in case 5, since the objective is clear, you need to accept with what value, enter the value to be added before tail. Let us understand the concept first. I'm going to the slide now. Okay. Add before the tail. Just concentrate on this logic. So assume that you are asked to write a C++ function, okay, which has to accept the root node and the value that needs to be added. Okay. So you always take P in order to do the traversal. Am I audible? Am I audible?
Yes, sir.
Okay. Yes, sir. So you create a temp, you use temp for creating a new node or deleting if at all it is required. Now in our case, this is for creating. So therefore temp is equal to new node. Okay, so in this, so as I have already discussed in the last class also, for any linked list problem, you need to first write the structure. I told yes or no? Yes or no? For any linked list problem which has been asked, a student has to mandatorily write the structure first, a linked list structure first. I told yes or no?
Yes, sir.
Yeah. So
Yes, sir.
you have to write a structure and then you draw a linked list diagram like this, make ensure that you are keeping the addresses very carefully. At the time of drawing, you can randomly write those addresses, but inside the nodes, you have to keep the address of the next node. Then only it is said to be a meaningful linked list. And the last node needs to have a null. Now, in this case, our requirement is we have to add a node just before the tail. Okay, so you use P in order to traverse. Now, what will be the condition? You have to start P starting from the head node. Okay, so that is node star P is equal to H. Then you are creating a temp node, right? And what is the place where you have to stop? You have to stop when P is equal to 145. So what do you mean by that? 145 arrow P next is 365. 145 arrow P next is 0 because 365 arrow P next is null. Okay, so your condition has to be start from P is equal to H until P arrow P next is not null. That means until my next fellow is the last bogey, you are moving P. So therefore, P will start from 400. 400 arrow P next is 500. This 500 arrow P next is 145, which is not null. So therefore, P moves to 500. Again, 500 arrow P next is 145. 145 arrow P next is 365. Again, this is not null. So P goes to 145 and P finally stops at 145. Why? Because 145 arrow P next is 365, which is again arrow P next is null, and null is not equal to null is false. So after the end of this while loop, you are pointing P, which is at 145. Clear? Clear?
Yes, sir.
Yes,
Okay,
sir.
so you have already given a birth to new temp, which is, I'm assuming the address as 1000. Okay, so now you have to be very careful because P arrow P next, once you change, you are going to lose this 365. So before you change P arrow P next to temp, you have to make ensure that temp arrow P next has to be P. Temp arrow P next has to be P arrow P next, isn't it? Temp, which is 1000, arrow P next, which is pointing to the address of the next node, needs to be P arrow P next. What is P? 145. 145 arrow P next means 365. That means you are striking this 365 and you are keeping this 365 here. Okay. And now P is already pointing to 145. Are you following? So 145 arrow P next has to be temp. So here you are striking 365 and then you are keeping 1000. Okay. So that means you are breaking this dotted link and then you are connecting a new node here and another link here. So there will be two links. Am I clear? Are you following?
Yes, sir.
Yes, sir.
Yes, sir.
So do you want me to code? Shall we come?
Yes, sir.
Coding? Okay. So enter the value to be added before the tail node. So let us assume that we have been taking y and k. So I'll take c in, probably k. Okay. Then what I'll do is r1 dot is write that function name. What was the function name I said? Add before tail. So add before tail. Okay, I am going to pass k. And this is the advantage of a member function because I don't need to pass the head node. What I'll do is if this function returns 1, then I'll say that cout the new node before the tail is inserted. Okay. Else I'll say saying that cout the new node before the tail is failed. Okay. So I'll stop break here. Now we need to implement this fellow which needs to return an integer, which is accepting an integer. So let us write the function prototype first. Let us write the function prototype. So it has to pass an integer argument, and then it is returning int. Then just above main and just above this destructor, which is at line number 86, I'm going to write the list is returning an integer with this function name with int, let us say n. N is the value that needs to be inserted. Okay, so what has to be done? You have to take node star temp, because you have to create initially pointing to null, node star p initially pointing to head. We have already created head. Okay. You have to traverse till while p arrow p next arrow p next is not equal to null. You have to change p, you have to traverse and you have to stop p by changing p as p arrow pointer to next. Are you following? Can somebody acknowledge? Use mic. Are you following?
Yes, sir.
Okay, so now p is pointing to the just before node. P is pointing to just before node. Now what you have to do is you need to create the new node. That means temp is equal to, but before this, there is a possibility that head itself can be null. This is how you can address different bugs. See, if it itself is null, then you can say that you return 0 because there is no tail, there is no head. So what user is asking is actually is a nonsense. So you are returning 0, and then there in main you are saying that I am not adding what is it, the tail. Just before tail I cannot add because head itself is null. So I'll come here only if it is not returning. This is how different bugs can be addressed. Now here temp is equal to new node type. Now here also you can probably validate temp. If temp is still null, that means it doesn't have the adequate memory. Then also you can return 0, isn't it? Yes or no? So if you come down, that means temp is not null and p is pointing to head. Then it makes sense. So all this can be written after this. Are you following? I'll cross verify whether head is null. Then I'll cross verify whether I'm in a position to create at least a segment of the discrete memory. Then I'll take P. Then I'll stop P just before the tail. Now P is pointing to a node which is just before the tail. Are you following? Can somebody come in?
Yes, sir.
Okay.
Yes, sir.
So now what? Now I need to make ensure that I don't lose the rest of the other bogies which are connected to the linked list. That means I'm going to insert this temp fellow. So temp arrow pointer to next node, I'm going to keep with the rest of the other bogie, that is p arrow pointer to next node. Okay. Now I have connected p arrow p next, which is the last tail. Sorry, this is tail actually, isn't it? P arrow p next is the address of the tail. So that tail will be connected here to temp. Now what? Now in temp arrow x, I have to keep the element k. N here, isn't it? And finally, p arrow p next has to be kept with temp. So node is inserted, or probably you can keep this fellow here. Then temp arrow x is n, and then return 1. You following? We compile. Any doubts?
Yes, sir.
Any doubts? This is how. This is why. This is why the modularity which is addressed by using C++ functions will be of good use. So let me start creating a head node, probably 5. I'm keeping a 5 table, 2, 10, again 2, 15, again to 20, again to 25. Let me display the list. 5, 10, 15, 20, 25 is the list. Okay. Now I want to add a node just before the tail. What is the tail node? 25 fellow is the tail node. So I want to add, let us say 44. So I have to choose option 5. Okay. So then let us say 44. New node before the tail is inserted. So let me check the display part. 5, 10, 15, 20, and in between 20 and 25 you got 44. Understood? It's very simple. See, it's very simple. You need to, this is a rule of thumb. Always take P to traversal, always take temp to create or to kill. Okay. If you are creating, you use new. If you are killing, you use delete. Simple. Whatever you want, make sure that P is pointing to your operational node. Can somebody come in? Are you following?
Yes, sir.
Okay. Right. Understood. Any doubts? If you are clear, I'll proceed with the other functions. Any doubts?
Sir.
Go ahead. Somebody is saying something? No doubts? Shall I proceed? Shall I proceed? Somebody tell something.
Yes, sir.
Shall I proceed? Or you have any doubts?
Proceed.
Okay, fine. Let me check how many participants. 58. Good. Okay, next. Add a node before the tail is done. Okay, add a node after a value k. I think this you can do. This you can do, right? Add a node after a value k. After a value k. After a value k means p arrow x. If it is double equal to, if it is not equal to k, then you traverse. P arrow x. If it is not equal to k, then you traverse. It is a bodiless loop. You have to traverse p, then you have to create a temp and then insert. So in this case, I am assuming that I want to add a node after 35. Means you are waiting until you get 35. Now once you get 35, then you are asking the user, you enter the new value, and let us assume he's entering 47. That 47 will be added in the same way like the way that we have added earlier. Clear? Clear? This I think I can skip of implementation. You can implement by your own.
Sir, what about if that node is 91?
Yeah, if that node is
K is
given, then
91.
it is same as adding just before, adding later the tail. So then also it is fine. So what happens is already P is pointing to 365. So P arrow P next is nothing but null. So in this statement, what happens is in temp arrow P next, it becomes null. So this node will become the last node, which is 1000 node. Okay, so 1000 arrow P next will become as a meaningful end of the tail. And then this 365, which is being pointed by P, arrow P next, which was earlier null, will be now getting replaced by temp. So there is no problem. Okay, so there is a problem here if the element itself is not there. Okay, so for example, you have traversed the entire list, and if the element itself is not there, then that is the bug that you need to handle. You have to say that you return 0. Whatever node you are looking for example, here I have considered a list. I have considered a list which is having 41, 35, 76, and 91. Assume that I'm searching for 29. Now 29 is not there. 29 is not there in the list. So once if P reaches null, and if any P arrow x is not equal to k, then I have to return 0 because I cannot add, I cannot insert. That bug I have not handled because I'm assuming that user is giving some input which is there. Did you understood? Are you following?
Yes, sir.
Okay, shall I proceed? Can somebody else respond? Shall I proceed?
Yes, sir.
Okay. Next, add a node before a value k. So just tell me what should be this before a value k. Before a value, that means you have to stop.
P arrow P next arrow X is not
Yeah,
equal to.
yeah, p arrow p next arrow x until this is not equal to k. That's it. Okay, so p arrow p next arrow x until this is not equal to k. You have to traverse the list and then you have to stop p once your next engine. I mean, sorry. Once your next bogey value is same as k. Here, I think this also you can do. Here.
Yes, sir.
Okay. Now next is count the total number of nodes. It's very simple. Count the total number of nodes. So assume that you have a list like this. That means how many you have to get? You have to get 4. So take a P which is pointing to head. Since already you are counting it as 1, you have to start iterating I is equal to 1 until P is not null. You have to increment I plus plus and then you have to traverse P, but make sure that you are not corrupting head. So therefore taking node star P is mandatory, and this is many times asked 2 marks question. Write a function, write a C++ function that needs to accept the root node of a singly linked list and return the number of nodes in that. This is an iterative logic. This also can be asked with a recursive logic. Recursion, it's very simple. You can probably take static int I is equal to 1 and then once P is null, you can return I, otherwise you do I plus plus and then you call the same function with the P arrow P next. Clear? You want me to implement? Clear?
Clear, sir.
Yes, sir.
Okay. Now next is, let us assume you are asked to delete the head node. Okay, so this is also simple. You are asked to delete the head node. First, there is a bug. In every function, there are many bugs. I'm assuming that a logical linked list is there and a meaningful insertion or deletion, we have written the logic. Example here, if head itself is null, then what will you delete? You have to return 0. So you take node star temp is equal to h. Okay, now notice that temp is pointing to head. Notice that temp is pointing to head and head is equal to head arrow p next. Then you delete the temp and you return the new head. Now after this function call, head is pointing to 500. Clear? Clear?
Yes.
Okay.
Yes, sir.
So probably I'll ask a question, a reflection spot question. Yeah, where is that? Yeah, here it is. What I'll do is let me copy this link. Allow. This has been a long time since I have logged in. Anyone with this link can respond. Okay, accept the responses. Now let me start sharing this. Okay, so you will get the 2 questions. Your time starts now for next 30 seconds. I'll be considering that as the attendance. Can somebody acknowledge, did you got? Can somebody acknowledge, did you got the list of questions?
Sir,
Okay, thank you. I think you'll be getting the responses also. Let me not show the results automatically.
Yes, sir.
Did you got the results also?
No, sir. Correct answers we have got it.
Yeah, fine. Just now I have disabled it. I think now it will not come for the other students. Only for those 6 students it will. Anyway, this is a sort of, keeping the students to be in attentive mode. Okay, last 10 seconds. I could see there is a good improvement of average score. Last 5 seconds. Forty-seven responses. 49, 50. So there are 10 students who are absent then. Okay, I'll stop here the responses, collecting the responses. Shall I stop? Anybody is making any more attempts? If anybody is making any more attempts, please let me know. Okay, I'll stop. Fine. So let us go through the. Let me post the scores. Let me post it to everybody. Let me go back. Oh, there are 55 responses. Okay, fine, good. So let us go through the questions. What is the answer for the first one? What will be returned if the following C++ API is called in main? Assume that H is the root node of a single linked list of type node star with p next pointing to the next node. Then get count. This will point what? What is the answer?
-1.
Yeah, it is -1 because you are excluding the last fellow. Okay, if it is p arrow, if it is p is not null, then you will get n. Or if you are starting I is equal to 2, then you will get total. Okay. Then second is if you compare this static or dynamic array with that of the single linked list, which of the following is correct? Both insertion of the element and the deletion of the element in array is tough compared with single linked list. Single linked list logics are very easy, isn't it? Yes or no? Any doubts on these two questions? Oh, no, your average is bad only because I think this was a 5 marks question. I have given 3 points to this fellow and then 2 points to this. So majority of you have answered the second one. Can somebody respond? You are not you are not interactive. Please respond. Respond as if you are sitting in the class.
Yes, sir.
yes, sir.
Yeah. So any doubts on these two questions? No, right?
No, sir.
I am asking the questions. I am only answering, and then I am only again asking. Please respond. Okay. Anyway, so let us go back to these other functions. Delete a node at k from root. This also can be done. If anybody want me to repeat, want me to implement, you tell me, I'll do that. Okay, so focus on this. You are asked to delete a node at the third node. That means a node with in this list, third node is nothing but node with a value 76 needs to be deleted. So what has to be done? Take again node star temp. You are now here you are using temp in order to delete a fellow. You are using P in order to traverse the list. Always P starts from head. Okay. Then what is this? Delete a node at K. That means third node. So already I has to be 1 because you are already passing head node. Then when I is less than K minus 1, that means up to 2. So when I is 1, P is pointing to 400. When I is 2, when I is 2, P is pointing to 500. There itself you have to stop because you have to delete this 145. Okay, so P points to 500. Are you following? Now you take P arrow P next into temp because that is the fellow that you need to delete. Now before deleting, temp arrow P next, temp arrow, temp is pointing to whom? Temp is pointing to 145. Temp is pointing to 145 because 145 is the one you are going to delete. Okay, so just before deleting, P arrow P next, which is P arrow P next, which was earlier 145, needs to be kept with 365. What is 365? Temp arrow P next. So once you have, that means you are killing this link, you created this link, and then you deleted this temp. Clear? Clear? Clear?
Yes, sir.
You want me to implement? You want me to implement? Let us implement one at least. Delete. Okay, so delete. It is delete at a place k. Okay, it is not delete with. It has to be delete at. Shall we implement this? Shall we implement this? Shall we implement this?
Yes, sir.
Okay. So I'm going to add. After this, we will be left out with only 3 more functions: one sorting and reversing the list, a singly linked list. What is this? I need to delete, right? So I don't need to return anything. So delete at. Okay, delete at a specific place int. Now I'll copy. Let me copy this function. Now just above the destructor, I'll keep on adding my new functions. This returns void, probably list, delete at, let us say k. I'm using the same notion what I have told in the slide. Now what? Node star p pointing initially null. Next what? Node star temp pointing to null. Next what? For or maybe while. Before that p has to point to head. Then while. Now I also need to initialize a variable int. So I'll use for int I is equal to 1, I is less than k minus 1, I plus plus. Then I'm going to traverse p as p arrow p next. So once I stop, p is pointing a node just before kth node, isn't it? So what I'll do is I'll make ensure that whatever P is pointing is caught by temp. Now temp is equal to P arrow P next. Okay, so that means P arrow P next is equal to what? P arrow P next is, tell me what should be written? I'm taking temp. Which is nothing but my next node. Next node is the fellow that I have to delete. So therefore, my P arrow P next must be equal to arrow P next. Then I have to delete temp. Then probably you return 1. Here, if you come across a situation where you are getting P itself as so here, if P itself is double equal to null, then is entering a value k which is beyond the list, beyond the number of nodes. On the other hand, if it itself is null, also return 0. So this is how you can fix the bugs. Can somebody respond? Are you following?
Yes, sir.
Yes, sir.
Okay, so I'm again changing this. Where is that delete at? So I'm changing this as int. Then I'm going down, and then one more option I'm going to add, which is, let us say, option number 6. Delete after k. Delete after k option. Then backslash in backslash. Then k6. K6. So what has to be done? I need to accept cout. Tell me which node needs to be deleted. Which node from head want to delete? Let us take that into probably k. Then R1 is an object. Del delete at k. This fellow returns 1. I'll keep this in if. Okay, and then I'll also write else. So if this is true, then cout deleted. Otherwise, I'll write there is a problem. Not possible to delete. Not possible to delete. Then I need to keep a break, otherwise my program will be getting terminated. Okay, clear? Shall I compile?
Yes, sir.
Okay. So let us create 1 and then maybe 12 table. Node 12, then 2, adding a node 24, 2, then 36, again 2, then 48, then 2, and then 60. And let us display. So I got 12, 24, 36, 48, 60. Now let us assume that I want to delete 48. It is with which node? This is first, second, third, fourth node. So delete after k, that means after third. Okay, so I'll take option 6. Then tell me which node from head you want to delete. I want to delete fourth node. Let me keep third node. Third node means he will be deleting 36 or 48. What will be done? It is deleted. Let us again print the list. So 36 is gone. 12, 24, 48, 60 and null. That was the third node. Yes or no?
Yes, sir.
12, 24, 48, this 36 is gone. So this is the main advantage of linked list. See, because if you take a scalable, I mean a linear array, then you need a entire huge volumes or huge chunks of heap in order to copy or duplicate the array and then copy the entire contents and then you do. Okay, whereas in linked list, it is more efficient. So that's why whenever there is a database management system that needs to be designed for extremely memory constrained applications, linked lists are preferable. Okay. So for any justification, if anybody asks, then you can probably take insert and delete as two functions, and you can technically illustrate that a single linked list is memory aware efficient, or memory wise it is more efficient. On the other hand, if the same requirement is being asked to fulfill by using a static array or by using a array at runtime, then you need huge chunks of heap unused memory. Okay, so which is not possible for memory constrained hardware platforms. Okay, clear? Clear?
Sir, in test what we have completed just now, that
Yeah.
is, I mean, balance test, static and dynamic you told us, sir, array.
Yeah.
What is meant by deleting of element in that array in static?
Okay. Technically, it is the question itself is wrong. Deleting the array means, what it means is deleting the element of the array. Value is important than memory, because when user is giving some value is important, because user doesn't care whether you are keeping it in the memory, you are not keeping it in the memory. It is up to you. Up to you means up to the coder. Okay, so deleting the element means deleting a value in the array. For example, just now we have taken 12 table. Okay, so in 12 table we have deleted what was that? The 36. Assume that you had a similar set of array like 12, 24, 36, then 48 and then 60. Now in that deleting in an array is not simple. Deleting that element 36 in the array is not simple, because you have to entirely shift up, and you need to request more heap, isn't it? Did you
Yes,
understand?
sir. Yes, sir.
Okay, so next is, what is this? Delete the tail node. I think this is simple. Subsequently, you can see the point is for insertion or for adding or for deleting. Always remember two fellows: p traversal, temp to create, temp to delete. Simple. Make ensure that you are moving p to the point wherever you want. Do your job, and then if you are creating, create temp. Use appropriate links. If you are deleting, delete temp. Make ensure that temp is pointing to the node that you are willing to delete. Okay, so this is delete tail. Same strategy. You have to use p arrow, p next until null. Make ensure that temp is pointing to p arrow, p next, and you delete temp. And finally, earlier when p arrow, p next, which was 365, now you make this as null. Clear? Clear?
Yes, sir.
Okay. Next, now let us do some sort of sorting. This is very simple way. There is a simple way to remember this. So now these are the unsorted elements. Okay, so let me put forward the code before explanation. Okay, so when you do the bubble sort, sorting in a linked list can be done in two ways. Please listen, all of you. Sorting in the linked list can be done in two ways. One is sorting the entire nodes itself. That means sorting the node addresses. For example, 41 and 35, they are not in order in bubble when I am asking to keep in ascending order. Okay, so when you are sorting the nodes itself, that means 500 nodes should go here and 400 nodes should come here. Then that is a tedious process. Why that is a tedious process? You are not only required to sort the node star pointers, but also you have to tackle carefully the links, because p arrow p next earlier was pointing to 500. Now this 500 arrow p next, which is again pointing to 145, needs to point to 400, because you are sorting. Are you following? This is approach 1. Did you follow it? Let me again,
Yes, sir.
this is a linked list. In this linked list, you are asked to apply the bubble sort. That means 41 and 35 elements has to be sorted. There are two ways. One way is don't change the value of 35 inside 500. Don't change value of 41 inside 400. Instead, you swap 500 here, 400 here. Nodes, swap the nodes. But swapping the nodes means you have to swap the links also. And that is very dangerous because next fellow's address also you have to keep in mind. Are you following? Are you following?
Yes, sir.
Instead, the second approach is don't touch the addresses, simply swap the values. Now I am using the second approach. That means let 400 be 400, let 500 be 500, 41 you remove here, 35 you remove here. This 35 you keep at 41 place and 41 you keep in 35th place. So I am using the second one. Am I clear?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
so let us understand the logic of bubble sort. So how we would have done this in static arrays? We use a double for loop. For int I is equal to 0, I is less than n I plus plus. For j is equal to 0, j is less than n minus 1, which is a non-improved simple bubble sort with j plus plus. If a of j is greater than a of j plus 1, this is our logic. We have to swap. Now simply this I you take P, this J you take Q. I is equal to 0 is nothing but node star P is equal to head, first fellow. Yes or no?
Yes, sir.
Okay, I is less than N is nothing but P is not equal to null. I is less than N is nothing but P is not equal to null. I plus plus is nothing but moving P. Okay. Similarly, node star Q, here J is equal to 0 means Q is equal to head again. Then what? J is less than n minus 1. That means earlier P is not equal to null. Now here Q arrow P next is not equal to null. Clear? Clear? Next, J plus plus means Q is equal to Q arrow P next. Can somebody start communicating? Are you following?
Yes, sir.
Following?
Yes, sir.
Yes, sir. Okay, now A of J, J is inner fellow. That means Q. Q arrow X is A of J. What is A of J plus 1? Q arrow P next arrow X. Q arrow P next arrow X. If these two guys are not in order, take int temp, take a backup, corrupt the backup fellow, and change the other fellow. Clear? Clear? Let me again repeat.
Yes, sir.
Two for loops. Outer for loop for int I is equal to 0, I is less than n, I plus plus. Now we are replacing this with node star is equal to head, P is not equal to null, P is equal to P arrow P next. Now for j is equal to 0, j is less than n minus 1, j plus plus is now replaced by for node star Q is equal to head, Q arrow P next is not null because it is n minus 1. And then Q is equal to Q arrow P next. Now I have to compare A of J and A of J plus 1. That is nothing but Q arrow X and Q arrow P next arrow X. If they are not in order, put it in order. What is the data type? Temp. What data type? Int. So you keep. Okay. So shall we complete this coding part? Shall we complete this?
Yes, sir.
I think I have already written the bubble sort function prototype there. Do bubble sort. Let me start writing the definition. That is just above the destructor. just above the destructor, what I'll do is void in list to bubble sort of void. So inside this, for node star p is equal to head until p is not equal to null, p is equal to p arrow p next, and then again for node star q is equal to head until q arrow next is not equal to null, then you change q is equal to q arrow p next. Okay, now what if let me again write what is this. This is nothing but for int I is equal to 0, I is less than n, I plus plus. What is this? This is nothing but for int j is equal to 0, j is less than n minus 1, j plus plus. Now what I am writing here is nothing but a of j bubble is greater than a of j plus 1. So that is nothing but if what q arrow x is a of j is greater than q arrow p next arrow x, then I have to swap. What should be my temporary variable? Int temp is equal to, let us take the backup of q arrow x. Now let us change the value of q arrow x with q arrow p next arrow x, again q arrow p next arrow x equal to temp. Okay, so we will apply the bubble sort and then we will display before sort and after sort. That is, let us say choice 7. Before I proceed, I think I didn't ask any question there. Anybody has any doubt? Bubble sort? Uh,
135 line Q arrow P next.
yeah, that is correct. 135 is q arrow p next. That is correct. Q arrow p next arrow x. Yeah, that is correct. Anything else? Good. Anything else? Q is equal to q arrow p next. Yeah, this is correct. Okay. Shall we proceed? Now let us keep 7. Apply bubble sort backslash n backslash. Okay, so I'll go to option 7. So I'll say case 7. See out. Applying bubble sort. So I don't need to do anything. I'll just call do bubble sort of function and I will not return anything because I can display again. Okay. So let us compile. Are you following? Let me add. Can somebody respond? Are you following?
Yes, sir.
Yeah. So let me add 1, 2, 3, 4 with zigzag order. I'm adding 3 first. Then I'm adding 5 next. Then I'm adding 1 next. Let me display. I got 3, 5, 1. Then 2, 4 needs to be added. I'll add 4 and then 2. 2, 2, and 3. So this is the unsorted list 3, 5, 1, 4, 2, X. Okay, now let me apply bubble sort. Applying bubble sort, sorting is done. So that means let me display 1, 2, 3, 4, 5 and then null. Okay, here, 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 here.
Yes, sir.
Okay. Similarly, selection sort. Same thing. Don't play with the node star type, but instead you directly change the values. Same thing. For int I is equal to 0, I is less than n, I plus plus. Just give me 1 minute. Yeah, I'm sorry. So P is pointing to H, P until it is not null. That is analogous to for int I is equal to 0, I is less than n, I plus plus. Okay. Similarly, for j is equal to I plus 1, what is j here? Q. What is I plus 1? P arrow P next. Simple. So node star Q is equal to P arrow P next until Q is not equal to null. Q is equal to Q arrow P next. What has to be compared? A of I. Who is A of I? I is outer index P. That means P arrow X is greater than A of J. J. Who is J? Q. Q arrow X. So compare P of P arrow X and Q arrow X and then swap. Are you following? Are you following?
Yes.
So can you complete this?
Yes, sir.
And the last one is inverse the list. This is a little tricky logic. So instead of PQ here, you take current, next and previous. Now please parse the program once. Okay, so you take 3 node pointers, current node pointer, next node pointer, previous node pointer, initially pointing to null, null, null. Okay, then you have to traverse till, starting from current is equal to head to current is not equal to null. Okay, then next is equal to current arrow P next. Current arrow P next must be equal to previous. Previous has to be current and current has to be next. Let us understand what is happening here. Okay. Where is that? Yeah, this is current. So earlier current and next and previous all are, I'm sorry. So earlier current, next and previous are, all are pointing to null. Now current is pointing to 400. So this is current. This is current, isn't it? Yes or no?
Yes, sir.
Okay. Now, where is the color tool here? I'm not getting. Okay, fine here. Okay, so next is pointing to null. Now here current is H. What is this? H is nothing but current is nothing but 400. So I'm getting 400 here. So I'm starting from 400 until my current becomes null. Now what is next? Next is equal to current arrow P next. What is current arrow P next? Current arrow P next is 500. So this is nothing but my next. I'm just writing, this is my next, this is my current. And now earlier current arrow P next, which was 500, 500 I am removing. Current arrow P next, which was 500, is updated with null, with the previous. What is previous? I'm keeping this fellow with null. Previous is null. Are you following?
Yes, sir.
Now previous is current. That means what is current? current is 400. Okay, now this 400 is now being pointed by previous. Why? Because I had to carry this to this fellow, to this address, because I need to reverse the link. So previous will become current and current will become next. Okay, so earlier current was 400, now current will be 500. Just make a analysis on a piece of paper, you will understand. Okay, so you want me to execute this, or will you do it by yourself? Why you're not at all interactive? What is happening? Am I audible?
Yes, sir.
Yes, sir.
Is it going beyond your head? You're not understanding. What is the problem? Are you following?
Yes, sir.
Okay, so you want me to implement or
Yes,
you want me
sir.
to skip? You want me to implement or you want me to skip?
Implement.
Okay, let us complete this. Then with this we will stop. I think I have taken some extra time now. Let me stop annotating. I don't know how to stop. Where can I stop this? Here exit. What is the time now? I took 4 minutes extra. So let me complete this inverse list and then I'm concluding linked list today. Okay. So by today's class, we are done with linked list. Okay. So let me add void inverse. Okay. So what I'll do is the destructor void list inverse void. So what you do is you take 3 pointers, but deliberately don't take PQR. Take current is pointing to null. Again you take previous. Again you take previous. Take previous, which is also pointing to null. Then you take last the previous and then next. Notice that there is p next. Now this p next also pointing to null. Now what? Initially current is pointing to head. Until what? Until this current is not equal to null. What has to be done? What has to be done is your current arrow p next, which is pointed, needs to be initialized to previous. Previous or next? It has to be next. Next has to be current arrow p next. Now your current arrow p next must be equal to previous, and previous is current is next. Previous is current and current is next. Finally, you have to tell, once you come out, then head is nothing but the last previous node. Okay, current, previous, next. Here. So let us execute this. Please respond. Shall I execute this?
Yes, sir.
Yes, sir.
We are inversing the list. Let us use case 8. R1 dot inverse. write a message saying that inversing the linked list. So once you have inversed, then again you can display. Okay. So let us compile. Let us compile. What has happened? Line number line number 4 in main. ECE. Inverse. Anything we have done wrong?
Line number 146.
Okay, let me check. Line number 152. 146 node star previous, that is correct. Previous, then next current arrow, P next is previous. Okay, let's check. Now let me add some list. Okay, I'll create first head node. Create the head node with probably 5, and then 2 with 45, again to 34, to 76, 13, then 2, 5. So let me display. This is the list what I have: 5, 45, 34, 76, 113, 5. I got 5 two times. 467. Now let me inverse it, which is 8. Inversing is done. Now let me print it, which is 3. Okay. Let me show the earlier list. Where was the earlier list? 5, 45, 34, 76. And 467 arrow 5 has to be there. 467 arrow 5, arrow 113, 76, 34, 45, 5, 76, 30. Okay. Okay. So let me again probably apply bubble sort. Can somebody come in?
Yes, sir.
Now we have done sorting. Now let me delete after the probably second node. 6, 2. Then let me again print 3. So I have deleted 1, 5, and so on. Anything can be done. Okay. So with this, we have completed single linked list. Next class, we will start stacks and queues. I'm sorry for taking 10 extra minutes. I advise you please practice all these routines which we have discussed, and I'll share both the PPT as well as the recorded video for your study purpose. Okay? Anybody has any other doubts? Please make ensure that you don't wait for your record work activity, because at no time, once the lockdown is up, which is likely to happen on 3rd centrally, but on 7th at state wise. So you may be asked to come to institutions, meaning to the college. So once you come, you will be directly facing the exams. You will be directly facing the exams. Okay, so it is completely dynamic. So there is this semester is clear that it will be completely the virtual e-platforms. Okay, so don't keep your record activity work pending. So please complete it. Please complete your record in all aspects. Okay, so you don't have to wait till if you have the scope of taking a printout, take a one-page printout with the Vasavi logo, and then take a photocopy. That means take the Xerox, but I'm sure Xerox are also not coming. Okay, so with this, let me stop here. If anybody has any doubts, you can interrupt me now. Okay, so I'll stop here and we will see the next class, stacks and queues.